Hello, hello, hello. Ryan here, primed to bring you another great audio article today. Actually, in the spirit of generosity, I'm going to bring you two. Seeing as they're just a wee bit short on their own, I'm combining two classics from Jamie Fristrom into one nice-sized audio article. If you've already forgotten, Jamie is the technical director over at Torpex Games, makers of Schizoid, hailed as the most co-op game ever. You can read more on him by heading over to his blog at www.gamedevblog.com. But enough of that, audio article number 13 is on deck, and it's time to get your learn on, right here at Industry Broadcast. Turnaround time. Enough general advice. Let's hit some specifics. One of the most obvious ways that you can optimize your team is by decreasing the turnaround time. By turnaround time, I mean the time between making a change and testing the change. Different sorts of changes obviously require different turnaround times. Some of them are as low as several seconds. Some as using edit and continue in Visual C++ to stop the program, fix something, and keep running. Edit and continue is probably the coolest thing since source control. After that, we get into the minute range. Changing one CPP file will usually require about a minute rebuild and then 30 seconds, great for prototyping new features. Changing an H file often necessitates a complete rebuild, which can take anywhere from 5 minutes for a debug PC version to about 30 minutes for an optimized PS2 version. This is coder-centric, but artists and designers are in the same boat. They make a change, they need to export data, build data, load a level. I find that when it takes more than a few minutes to see a change in the game, I lose flow. I drop out of the zone. I start browsing websites, I go get a drink, I wander over to someone else's office, post another article on my blog, whatever. Often the build finishes or the level loads and I don't even notice, creating additional idle time. And I forget what the hell I was doing. Frequently, when I see people goofing off at work and I go to investigate, there's a reason. They're waiting for data to build. They're waiting for a sync to finish. Although there are some conscientious people that sit and meditate on what they're working on while they wait for turnarounds, and those guys are often the best employees on the team, for most people, there's a point where turnaround time costs much more than just wasted time spent waiting. By way of comparison, I've done some programming in interpretive languages, scripting missions for our game or writing database clients in Visual Basic. And currently, I've got a side project going on at home where the build is still under 10 seconds. These experiences are pure pleasure. Flow is achieved. I feel like a potter at the wheel, sculpting my software. Some coders would be horrified by that analogy, as it shows a code like hell inclination, rather than an inclination to write correct code the first time around. But guilty as charged. Still, just because fast turnaround times allow us to be bad programmers, it doesn't mean that we have to be bad programmers. Or maybe we should go back to job control and mainframes because that encourages us to triple check and code review before we even compile. But enough preaching. Here are some techniques to lower turnaround. I'm going to start with coder turnaround because that's what I know best. But on your project, code might not be your biggest problem. You might be more worried about getting as much art or as many levels into your game as possible, in which case you should focus on content turnaround. Start by measuring your build times. You can't control what you can't measure. Just like optimizing code, optimizing build times requires an iterative process of measurement followed by single variable changes. In Visual C++, we can pass in the Y3 option when running msdev.exe, and it will time your builds. Cool little undocumented feature. With .NET, go to Tools, Options, Projects, Build Timing, and set it to Yes. With command line tools, you can use %time%. Use meta files. Synaptic once had a C compiler called Lightspeed that they had what they called a missing link. The link was almost instantaneous. Their secret, I believe, was that they didn't link. They just compiled all the C files in one big C file, and then somehow incrementally compiled single modules. I believe this because files listed later in the project could refer to the one global variables declared in the earlier modules. Pure evil, obviously, especially if you don't know the compiler is doing it. Still, maybe we can use this for good. If you create meta files, that being CPP files that include a dozen or so of your real CPP files and nothing else, you'll see your build time improve, partly because your link time will go down and mostly because your H files will only be compiled once per dozen files instead of once per individual file. But then you have a trade-off. When making an isolated change to a CPP file, your build time for that single file is now longer. So it's really up to you to find the optimum balance between individual file compile time and full project compile time. One thing you can do is to make a files_fast.cpp meta file. If you're going to be working on a single file for a while, you can copy that file to filesfast. It's the only file you put in there, so it takes very little time to rebuild. The best of both worlds. If you have foresight to know which files you're going to be working on, of course. Now, the downside to meta files is that it butchers your modularity. Suddenly, programmers working on one module could, in theory, see the static variables and declarations in another module and violate their encapsulation. Use precompiled headers. I found that most programmers don't know how to use this feature with Visual C++. You can't just go into your project settings and turn on Use precompiled headers and expect it to work. What you need to do is this. Make a header file that includes your other commonly used but rarely changed headers. Microsoft usually calls theirs stdafx.h, whereas I call mine global.h. Obviously, things that might go in here are the Windows and STL headers. I have a CPP file that includes that file and nothing else. I call mine precompt.cpp. In the project settings for this file, turn Create Precompiled Header on. For all of the other files, either include global.h as the first line in the file, or set Use Precompiled Headers to off, and watch your build times improve. One warning, however. Everybody on the team needs to know how precompiled headers work. A problem I frequently see is that a new programmer tries to add a new CPP file to the project and gets an error message about the precompiled headers. So they go into the project settings and turn the precompiled headers off for everything. Voila, it works again. Forgive them, for they know not what they do. There's a theoretical minimum time your compiler will take to do a complete rebuild. If you compile and link a 1,000-line program and measure how long it took, you can then come up with a pretty good estimate of how fast you're going to be able to get your 200,000-line game to build, unless you use a distributed build environment. We haven't really bothered with that, because our full build times are around 5 minutes, and products like Incredibuild only promise to get that number to around 3. Now, if we had a 10-minute build time, we would have signed up for Incredibuild yesterday. And where I would normally say adios and bid you all adieu, I'm just going to roll right into the second part of this article, or the second article to be more accurate, which is titled Content Turnaround. I discussed the importance of turnaround time in my last column, and pointed out that coder turnaround may not be the most important area to hit. One of the things that can really slow game developers down is long level load times. This is bad not only because the user will probably suffer the same long load time as well, but also because of how much it retards the developer's effort. This is a lesson that I've learned the hard and bitter way. I am currently working on the first project in years where our load times are tolerable. Here is how I was sucked into this trauma. Way back when, I liked text files. The game would read in text files for the world data, parse the text, and there would be the world. Almost everything was text, including the meshes. At first, everything seemed okay, because the amount of data was small and so were the load times, so optimization was not a high priority. Eventually, optimization becomes a priority, but the amount of optimization that you have to do to make levels load fast is enormous. Our solution, which I discussed in our Draconis Postmortem, solved the problem of load times for the end player, but actually made our workflow even worse. I like to think that we were in the wrong place at the wrong time. The old school PC developers and the console developers knew better than to have text file formats. They were fairly new, and the PC hard drives had gotten fairly powerful, so it seemed like text files were the way to go. In fact, text files were a fairly workable solution for Die by the Sword, so we didn't know any better. I thought I was following C.A. Hoare's advice, that being premature optimization is the root of all evil, which implies that you should write your code and then only when you discover it's too slow, optimize it. As with rendering, you should be thinking from day one about how to make it fast. But text files have their advantages. Humans can read them, for one. A disadvantage is that humans can edit them. If they're files you export from 3ds Max, this can create problems for your toolchain when someone tweaks a file to create an effect, and then people want to go back and edit the original 3ds Max file. More importantly, text files are independent of the final optimized in-game data structure, so when the code changes it can remain compatible with the old format, and the content people don't have to go into Max and re-export everything. This is huge, because you really want to be able to tweak your data formats at will without requiring weeks of artist overhead. Here's our current solution. We use intermediate file formats that are text-based. We write tools that convert these files into a format that is as close to possible to the binary format that the target platforms and development systems actually use. Avoid pointers. When you need pointers, store offsets in the file that the program later fixes up. These tools must run on a PC. Having to run a console development system to build your data is no fun. This is the best of both worlds solution. You can still read the text files, but loading the binary file takes as little to the theoretical minimum of the media as possible, and when the format changes, a batch file can convert everything. Of course, doing this is non-trivial. It took 2 of our best engineers working for around 4 months to convert all of the various objects and file formats into these fast binary representations, and there is still 1 or 2 more files that never got converted. You have to worry about the in-game data and tools staying in sync. The way we did this was to have it be one and the same codebase. It builds a tool if you set one compiler #define, but builds the game if you set another. How the system works is beyond the scope of the article, and I hope one day Game Developer will pay Greg Taylor, the guy behind it, to give it the treatment it deserves. This just offloads the text file parsing from the game to the tool. The parsing still has to be done. A lot of time still has to be spent. But what you've done now is move the time from a single every run of the game to a single setup period after the user gets new data. Flow can be achieved because the turnaround on the small changes is fast. Our load times are way down. For example, when editing a game script, I can compile the script, run the game, and test the script in a matter of seconds. Another trick for fast load times? WAD files. WAD files are more straightforward. Seek can take 1/3 of a second, especially if you're reading off a DVD. If you combine all of the files a level needs into one big file, you can save, number of files, divide by 3, seconds. Video games often have hundreds and hundreds of meshes and textures, so we're talking about saving minutes. Again, it's a good idea to have a command line tool to build the WADs. Another thing that brings the content team down is large gits from the asset control system. If you're one of the few developers out there who still uses SourceSafe, stop. Use Perforce. We haven't shipped a product using Perforce yet, so caveat emptor. The speed is incredible. We used to spend 15 to 30 minutes a day just getting everybody's latest data into the local machines. Now it usually takes less than 1 minute. Even though Perforce costs about $800 a person, and it has to be somebody's part-time job to administrate, because eventually Perforce will get as slow as SourceSafe if you don't give it love, it doesn't take long to pay for itself in employee time. Coupled with its reliability, the atomic changes in the source, the synchronization of code and data, the fact that it deletes files on our local machines when we're done, I can sync to anywhere in the history of our current project. It's just fantastic. And their customer support? I send them an email and I get a response in 15 minutes. Try doing that with SourceSafe or CVS. I do miss one feature CVS had. If somebody submitted an evil change, I could easily undo it by typing CVS update-J, date plus time after the evil change, minus J, date plus time before the evil change, *.*, and CVS would merge the reverse of the change with our current sources. It sounds scary, but every time I tried it, it worked. And there we go, ladies and germs. 15 minutes later, we have 2 great articles by Jamie Fristrom down the hatch. As always, I've been your host, Ryan Wienko. I hope you've enjoyed this a little bit of insight today. Thanks for tuning in and giving myself and IndustryBroadcast.com the opportunity to bring the collective insight of the gaming industry to, you guessed it, your ears. Oh, and in case you're wondering, a tune that good? Well, we just need to play that whole damn thing one more time.